All right. My name is Merki. I'm from a company called CognitiveVR. We do analytics for virtual reality, augmented reality, mixed reality, any type of word plus reality you can think of. We do it as long as it's immersive. So ARKit, that announcement's really exciting for us. The fun part about doing analytics in VR and AR and anything immersive is that the number of inputs that you now have is exponentially higher than in the kind of four traditional pieces of technology we've had before in the PC, Web 1.0, Web 2.0, and mobile. Everything was kind of based on a click, a tap, a drag, a pinch to zoom. These were great, but these also were very easy to control because it was a rectangle that was either in front of your face or in your pocket. The big green login button that you wanted to measure was exactly the same place it would be on the rectangle, and it was really easy to control. But now, of course, that big green login button probably doesn't make sense in VR AR, and it's not going to be easy to control where that is. People are different heights, they have different arm lengths, they have different ways of perceiving the world. They might have different contexts, physical contexts. So it's not at all easy to control any of that. To make it even harder, we're now trying to analyze how people behave relative to changing contexts. So immersive is a lot of fun, but it's also much more complicated. My favorite behavior analysis in sort of the traditional media is the Google reCAPTCHA technology, the little I'm not a robot button that almost seems too simple. That tracks your mouse movement plus IP address plus network plus geography plus variables that probably they keep secret. And it determines with some certainty that you indeed are not a robot. That's basically taking the massive extent of everything they can possibly track with a standard piece of technology and applying that to a really cool network, sort of security or anti-spam piece of software. In VR, you can actually do the same thing, but the reason that it's exponentially more difficult to track user behavior in VR is because while you can do something like tracking mouse movement, now tracking like a controller is not a 2D plane with an XY coordinate, it's an XYZ coordinate, plus you have two hands, plus you have a headset, plus you potentially have retinal tracking, plus you're in a potentially undefined context in AR or MR. So that's a lot of fun. Plus there's new inputs too. I mentioned gaze and retinal tracking. Of course, positional tracking is also difficult because not only can you walk around with your Vive on or your HoloLens on, you can walk around relative to your virtual environment as well. So there's kind of almost two ways of tracking position. And there's also object interactions. You know, you can pick up the branded Coca-Cola can or the joystick in your airplane flight simulator training experience. Or maybe the whole point of your flight simulator training experience is that you shouldn't be looking or interacting with something. So that's actually another big data point that is potentially high there. And voice is a new input. Like I mentioned, hand movements and even user details. So I'm tall, some people aren't. I have long arms, some people don't have long arms. My voice might be different. I have different language than some people. There's all these new inputs that are able to be tracked, but also really difficult. So what we tried to do was wrong at first. We built these fantastic input systems for tracking these inputs, but we took the exponentially hard to track beautiful new inputs and we put them on a relatively simple chart and graph, right? So we had temporal context. We knew that over time, a user might have interacted with some virtual object or something like that, but that fundamentally wasn't that interesting. So what we did do is we built a tool called Scene Explorer. And so what we noticed is that the 3D context of where stuff happens virtually or with an augmented reality is actually really important, and it makes much more sense. So we took all the geometry from your virtual reality scene, we threw it up to WebGL on this viewer, and while a user is in their their session, we actually record 10 times per second their positions. So that's the XYZ coordinates of their head, their hands, where they're looking at, what inputs they're doing, any voice input that they might have triggered, and any other dynamic object interactions. And we're also mapping a heat map, a visual heat map of their gaze. So now not only do you know kind of what they're doing, where they're doing it, what they're also looking at. So we built this train conductor simulator. We brought it to a conference, and I thought this was a great use case of how kind of funny it is to try to track what people are doing in VR. It was very simple. We had a chair. We told them to sit down. You're the train conductor now. Here's 5 or 6 levers you can pull. And then after the experience, they could kind of take the headset off and see, yes, indeed, you looked where you thought you looked. And when we went to the aggregate mode post-conference, we wanted to confirm that, yes, people were looking at the right places. But actually, if you look in this is the aggregate mode of our tool. There's no red sort of heat hotspots where you might expect them to be, right? The dashboards at the front are all blue. And that's weird because everyone was supposed to be looking at the dashboards and controlling the train. Instead, we see this weird red, really, really red, bright red part in this weird part of our ceiling of our train, which doesn't make any sense because obviously people should be pulling the levers. And when we went into positional aggregation mode, so this is aggregating the average position of people during the scene, again, we saw this weird curve towards the chair and not really centered around where we thought people were interacting. It turns out whenever we would take people out of our little train conductor demo, we would put the headset on the table, and it was angled up. So there was minutes and minutes and minutes and minutes of this head looking at the ceiling, and thereby generating this heat map in the ceiling. So we've learned to do our demos a little better for next time, but that was an interesting piece that we didn't really, it was kind of an accidental insight that we found. But those types of learnings are really interesting because if you do your demos properly and you have kind of the start and stop of your tracking, then you can start getting aggregates of things like retail stores, things like product placement, things like real training simulators. We have customers that are building cars in virtual reality, and instead of building a $2 million or $3 million clay model and wasting thousands of work hours building something and then iterating upon physical materials, they take their CAD model, put it into virtual reality, strap a headset onto their executives, and their iteration cycle becomes weeks instead of months and months, and then we can even aggregate and track how people are interacting with their products. The other fun part is that you can start building new context for user surveys and voice feedback. So we have this tool called Exit Poll where you can build basically a questionnaire, pop it up in VR, and they can say, yep, this was a happy face, I like this, or sad face, I didn't like this, or kind of multiple choice. You can even do voice feedbacks, right? So did you like this car? No, I hated it, blue sucks, right? And then you can get that feedback right into. The hard part for us is that we've learned that all of this data is great and we can get some funny train conductor ceiling headset looking at the corner insights very quickly and help iteration cycles. The hard part is taking all of that data, which is 3D positions times n number of controllers times 10 times per second for each user, and then making that intelligent, right? So machine learning with something like that is a tough mathematical challenge that we're actively working on, but I think we're going to get there. The other part is that when you don't have a set 3D spatial context, so if you're in AR with AR kit, that's very difficult because how do you track a person's interaction with an environment when their environment is like the real life? So building adaptation for that intelligently with things like Apple Kit or AR Kit or HoloLens or Meta, going to be pretty fun. And finally, industry standards are going to be something that I'm curious to see because in traditional media, CPM is one of the most common words you can say on the internet. But what's that going to be for VR, right? Are we going to be talking about clicks? Are we going to be talking about gaze seconds per branded object? I don't know. And then finally, emotion detection, right? So there's a huge difference between picking up a Coca-Cola can and like enjoying it or feeling a connection to the brand and just like throwing it in the garbage. So both of those are easy to measure, but it's hard to determine what a person's actual sort of engagement was with that. Oops. And that's it. I know we're running out of time, so I kind of went a little quicker. But yeah, please send me an email or come find me afterwards, and we can talk more.
Let's give him a round of applause, everyone. Thanks. Thank you, Rob.